Hello everyone. After watching the previous video, perhaps you are wondering now how to determine the generation and the architecture of a particular GPU. Let me illustrate this with a couple of examples. Suppose you want to learn more about the specifications of GPUs like the RTX 3090 and the A100 GPU. How would you go about it? How you know the specifications of such GPUs? The answer to this question is straightforward. Simply conduct a Google search for the A100 GPU Tech Power Up. By the way, Techpowerup is a website hosting an extensive database of GPUs from various manufacturers. Okay, so all you need to do is to write on Google A100 GPU Tech Power Up and then click enter. And after searching, click on this link here to access the details or the specifications of this GPU, of the A100 GPU. Also, you should follow the same steps to explore the specifications of the second GPU, the RTX 3090 GPU. Let's do it. Just write RTX 3090 and then take power up, click enter, and open the link. Let's now make a simple comparison between the two GPUs. First, we have here the electronic chip name. The GPU chips will be explained in one of the next videos, okay? So we are going to leave it now. But we are going to read only the name. And as we see, it is GA100. Then this is the number of cores that exist in this GPU. It's around 7K or 7,000 cores. Compare this to the RTX GPU, you can see that we have here more than 10K or 10,000 cores in the RTX GPU. You can see here also that we have numerous specifications that explain the different capability of each GPU. But I'll skip that now to focus only on the generation and the architecture in this video. But in another videos, we are going to discuss more specifications. But I want you to keep in mind that this number here, the 6,192 cores, these cores are exclusively for handling the single precision operations. This number not representing the overall core count for various operations. The A100 GPU also contains different core types. For example, it contains cores for handling the integer operations and for handling the double precision operations. And we are going to delve into this and explain it in depth from the official white papers and data sheets. But this will happen in the forthcoming videos, not in this video. Right now, let's focus our attention on understanding the generations and the architecture of these GPUs. Take, for example, the RTX 3090 GPU. As shown here in this part, the generation is GeForce 30. I'm going to skip the number now and just focus on the generation name. And as we see, it is GeForce. Do you remember what GeForce is designed for, as we explained in the previous video? It is designed for normal desktops or laptops or even workstations. Here, we also observe its architecture, which is the Ampere architecture. Now, let's see the A100 GPU. As highlighted here, the generation is Tesla. And as we said in the previous lecture or the previous video, the Tesla generation is dedicated for usage in the high performance computing servers and supercomputers. Also, and surprisingly, the A100 GPU shares the same Ampere architecture as the RTX 3090 GPU, despite being designed for different applications, okay? And we discussed this many times in the previous video. Okay, I have a very important question here. How do we visually confirm this distinction? I mean, how do we confirm the distinction between the GeForce and the Tesla generations? Okay, to address this question, let's examine the GPU images. When examining the images of these GPUs, you will notice that Tesla GPUs typically do not contain an onboard cooling fan. There is no cooling fan. For example, we said that the A100 GPU generation is Tesla. So if you look at the A100 GPU image, you will not find any cooling fan. The same goes for the V100 GPU. It is also included in the Tesla generation. So if we search for any picture for the V100 GPU, you can see that it doesn't contain any cooling fan. The reason for that is these GPUs are intended to be used in the high performance computing environments. And these environments contain external and more robust cooling systems in place. So, for example, if you search for any supercomputing around the world, you can see how complex the environment is. These environments are complex and it contains a robust cooling system. On the other side, GeForce GPUs, such as those in our computers and desktops, for example, the RTX series, those GPUs are commonly equipped with a built-in fans. These fans are necessary for dispersing heat in the standard desktops or workstation environments where these GPUs operate. Okay, so this is how we visually confirm the distinction between the GeForce and the Tesla generations. In the Tesla GPUs, there is no cooling fan. In the GeForce GPUs, we have a cooling fan. And the reason for that, the environment where these generations are used.